Venus is 900 degrees Fahrenheit. That's hot enough to melt lead, hot enough to make tin flow like water. And here's the kicker. Venus is almost twice as far from the sun as Mercury, yet it's 300 degrees hotter. How is that even possible? It breaks everything we think we know about how planets work. But the answer is one of the most terrifying processes in the universe, and it's not what you think. By the end of this video, you'll understand why Venus became a hellscape, why distance from the sun doesn't matter as much as you think, and what this means for our own planet Earth. Let's start with the basics. Mercury is the closest planet to the sun, about 36 million miles away. It gets absolutely blasted with solar radiation every single day. Mercury's daytime temperature can hit 800 degrees Fahrenheit. That's incredibly hot. But here's where things get weird. Venus, sitting at 67 million miles from the sun, is consistently 900 degrees. Not just on the day side, not just at the equator. Everywhere, all the time. Day, night, poles, equator, doesn't matter. 900 degrees, constantly. Mercury, meanwhile, has wild temperature swings. 800 degrees on the day side, but drop to minus 290 degrees at night. That's an 1100 degree difference. So what's going on? Why does Venus, farther from the sun, stay hotter? And why doesn't Venus cool down at night like Mercury does? The answer is atmosphere, or more specifically, the lack of atmosphere on Mercury versus the absolutely insane atmosphere on Venus. Mercury basically has no atmosphere. It's essentially a vacuum. When the sun hits Mercury's surface, it heats up fast. But when the sun disappears, that heat radiates right back into space. Nothing to trap it. Venus, on the other hand, has an atmosphere so thick it makes Earth's look like a gentle breeze. We're talking 92 times the pressure of Earth at sea level. Standing on Venus would feel like being 3,000 feet underwater on Earth. The pressure would crush you instantly. But that's just the beginning of Venus's problems. That atmosphere is 96% carbon dioxide, and this is where the greenhouse effect comes in. The real reason Venus is hotter than Mercury. Here's how it works. Sunlight passes through Venus's atmosphere and hits the surface. The surface absorbs that energy and heats up. Then it tries to radiate that heat back out as infrared radiation. But carbon dioxide is transparent to visible light, but opaque to infrared. So the heat can't escape. It's trapped. The atmosphere acts like a blanket, or better yet, like a greenhouse. More heat comes in during the day, but it can't leave at night. So the temperature just keeps building and building until you reach equilibrium at 900 degrees. This is why Venus doesn't cool down at night. The thick carbon dioxide blanket keeps all that heat locked in. Day and night, the temperature stays constant. But wait, there's more. Venus also has clouds. Thick, dense clouds covering the entire planet. And these aren't water clouds like on Earth. They're clouds of sulfuric acid. Yes, sulfuric acid, the stuff that dissolves metal. These clouds reflect about 75% of incoming sunlight back into space. So Venus actually absorbs less solar energy than Earth does. It reflects more sunlight away. It's still 900 degrees. That's how powerful the greenhouse effect is. Let's talk numbers. As of 2026, we've learned even more about Venus's atmosphere from recent missions. The European Space Agency's Envision probe gave us incredible data. The atmosphere extends about 250 kilometers above the surface. Wind speeds at the cloud tops reach 300 miles per hour. That's faster than the worst hurricanes on Earth. But here's the crazy part. Venus rotate incredibly slowly. One day on Venus lasts 243 Earth days. Yet the atmosphere whips around the planet in just 4 days. This is called superrotation, and scientists still don't fully understand it. The atmosphere moves 60 times faster than the planet itself. It's one of the great mysteries of Venus. The atmosphere pressure at the surface is so intense that it changes how heat moves. Heat transfer works differently at 92 atmospheres of pressure. In fact, at ground level on Venus, carbon dioxide becomes so dense it acts more like a fluid than a gas. It's almost like being underwater, but underwater in boiling acid. Every spacecraft we've ever landed on Venus has been destroyed within hours. The heat, the pressure, the acid, nothing survives. The Soviet Venera probes in the 1980s lasted about 2 hours max. Now here's the really mind-blowing part. Venus wasn't always like this. Scientists believe Venus once had liquid water oceans, just like early Earth. Venus and Earth formed around the same time, about 4.5 billion years ago. They're similar in size, mass, and composition. They're practically twin planets. But something went catastrophically wrong on Venus. The leading theory is a runaway greenhouse effect. As the sun got brighter over billions of years, Venus started heating up. The oceans began to evaporate. Water vapor is also a greenhouse gas. So more water vapor meant more heat, which caused more evaporation, which caused more heat. A vicious cycle. Eventually, all the water evaporated. Ultraviolet radiation from the sun split the water molecules. Hydrogen escaped to space. Oxygen bonded with surface rocks. The water was gone forever. Without water, there was nothing to remove carbon dioxide from the atmosphere. On Earth, water and life cycle carbon dioxide through rocks and living things. Venus had no such system. Volcanoes kept pumping out carbon dioxide. It just accumulated in the atmosphere. Over millions of years, it built up to 96%, and the temperature soared to what we see today. Now you might be wondering, could this happen to Earth? And the honest answer is yes, theoretically. But it would take a massive change in conditions. Earth is farther from the sun than Venus, which helps. We also have plate tectonics that recycle carbon dioxide into the crust. And we have a strong magnetic field that protects our atmosphere. Venus lost its magnetic field billions of years ago, which allowed the solar wind to strip away lighter elements and water. Earth's magnetic field prevents this. However, human activity is adding carbon dioxide to Earth's atmosphere at an unprecedented rate. We're conducting an experiment in real time to see how much our planet can handle. Venus is a warning. It shows us what happens when greenhouse gases run wild. When feedback loops spiral out of control. When a planet loses its ability to regulate temperature. The difference between a habitable planet and a hellscape might be smaller than we think. Venus teaches us that planetary climates can reach points of no return. So to answer the original question, Venus is hotter than Mercury because of its thick carbon dioxide atmosphere, creating an extreme greenhouse effect that traps heat. Distance from the sun matters far less than atmospheric composition. If this video blew your mind, hit that like button and subscribe to your Space Wizard. We make the universe accessible and mind-blowing every single week. Don't miss out on the cosmic journey. Venus reminds us that we live on a fragile, precious world. Understanding why Venus became hell helps us appreciate the delicate balance that keeps Earth habitable. That's the real magic of planetary science.